Hello, my name is Ankur and I'm from Team 19853, and today I'm going to be explaining what our robot is, the components of our robot. So to start it off, I'm going to start off with the key components. So we have our control hub, which has four motor ports and like 6 servo ports. We're not using any expansion hubs. And then we have our battery on this side, and then we have our power button right here. After that, I want to explain our drivetrain. So we're using a standard Gobilda Mechnum drivetrain. We have Mechnum wheels on all 4 sides, powered by 4 Gobilda motors, and that's the drivetrain. Then we have our arms and our Viper slide. So we have a 2-stage Viper slide, and we're using 2 servos, one for our parallel beam attachment and one for our claw to open and close. And then we're using a motor to power our Viper slide. Since we're only using 1 control hub and we have 5 Gobilda motors, so that's why we're using something called a Spark Mini. It's basically where it provides power to a motor, but instead of using a motor port, it uses a servo port to take in information from the control hub. And then last but not least, we have other things or other features such as our beams. This is here to stabilize our Viper slide, and the wires to provide info. Thank you for watching.
Hello, my name is Rithvij. I'm in FTC and I'm on team 19853. Today I'm going to talk about Mechnum wheels. So Mechnum wheels are very versatile, and they allow a robot to make a 360-degree turn without using much space. Like the space besides it and just a little bit more based on the width of the robot. So a normal robot would require this much, but a Mechnum wheeled robot would only require this much. So you might be wondering, how does this happen? So on the Mechnum wheels, they're positioned with a 45-degree angle and drive, and this happens because there's rollers that are put at 45-degree angles, and then the rollers are positioned like this to give it a diagonal motion.
Guys, he's actually doing the script.
So that if when you put a force in the diagonal direction, because if you go forward or backwards, the diagonal direction will cause it to also be able to slide and rotate. Okay, so if we want to look at some combinations, if we had forward right, we'll be FR. If we had forward left, we'll be FL. If we had backward right, we'll be BR. If we had backward left, we'll be BL. So it would look like this if this was the front and this was the back. So in order to go sideways, we'd have to have the front left and the back right move forward. So forward and forward. We need FR and BL to move backwards. Backwards. All right. So this will go sideways because if we take this motion, because the wheel is at a 45-degree angle, and so since it's a 45-degree angle, the front will look more like this, and the back will look more like this. So when we look at this, the two forces are canceling out, and they'll only move sideways. So this would be pushing this way, this would be pushing this way. So the forward movement is canceled out, but you can still go side to side. Okay, so now let's move on to forward or backward. This one is pretty straightforward. It just basically means that all of the wheels are going to either move all forward or all backwards. And then if we want to go diagonal, we would not have forward left and back right and go forward like this. And we would want the other two remaining motionless. So this and this would not move. This would cause only a motion of this way to go, and so that would make the robot go this way or this way based on if you put power forward or backward. And so finally, if you want to go 360 degrees, you'd have to move your forward right wheel forward. You'd have to move your backward right wheel forward. And you'd have to move your front left wheel backwards and your back left wheel backwards. So these forces are colliding and they both are, on this side, both of them are like pushing this way and both of them are pushing this way. So it causes it to start to circle. Okay, so that was basically it. So thanks for watching. Please like and subscribe.
Hi, my name is Karthik and I'm from FTC Team 19853 Roboteers, and I'm going to be talking about the drivetrain. So the drivetrain is the main part of the robot. It holds everything in place, and so the three components of it are the main base with the wheels. We use Mechnum wheels to help us go from any direction. We can slide, go forward, go backwards, and turn. And this is our control hub. This is where all the programs are stored, where we plug in the motors, where the servos for the arm and everything is plugged in. And then this is a battery pack, which we have to charge, and this powers up the entire robot. And this is pretty much our entire frame. Thank you.
Hello everyone, my name is Mernoli, and today I'm going to be talking about servos and the different parts and all of the things that they do. First of all, what is a servo? A servo is basically an advanced or specialized motor. However, what they do is that they are an electromagnetic device which enable a machine to rotate on certain parts. They comprise of many things. One is a rotating shaft. It's basically a shaft that rotates about the gears. There's an electric circuit to connect it to the parts that you want it to move on. And there's a motor to generate the electricity. So there are many ways to start or basically enable a servo. And it is a digital type. So a push of a button or a flip of a switch activates it. That means you don't have to do it manually. Otherwise on a motor, you can operate it manually. Motors are also analog and they are in continuous motion, but servos do one step at a time, or basically one unit at a time. With the unit we use are ticks, so that is why they are not used in wheels, because otherwise you would have to keep pushing a certain button in order for them to move. In our robot, the servo is found in our arm and our claw. One click of a button makes the arm open up and makes the claw open. And what happens is you use a servo there instead of a motor is because it generates more power and holds a greater amount of torque, which allows it to keep it in place. While in a motor, if you put it in that certain area, it would fall down back to its weight or by closed by its claw. These are used in many industries, but I have explained it how we have used it in our robot. I hope you understood something from this video. Thank you.
And I'm part of the team 19853 Roboteers. And today I'll be explaining the purpose of the parallelogram beam and our robot, which if you don't know is used to connect our Viper slide to our claw. The reason we use this parallelogram is to keep the claw vertical at all times and perpendicular to the ground. This is an angle. So as you can see in these two figures, the claw is going to always remain at the same point, and if we power on one side, the resulting motion will make both sides be parallel to the ground, no matter what. And that's why we use it in a robot. Thank you.
Hi, I'm Adish and I'm part of Team 19853, and today I'm going to be talking about the Viper slide we use. So the Viper slide is used so it can extend and reach higher height limits when you stand it upright. The regular base where everything is collapsed on top of each other is 15 inches. But when you add the two extra slide elements, it's a two-stage Viper slide, it'll be an extra 19 inches. So together overall it would be 34 inches. So Viper Slide, the material that it's made of is a steel material. They're steel slides. These steel slides provide lots of durability and great strength too. And in the middle, as you can see, there are different sections. In these sections, there should be some ball bearings, keeping limits, which actually provide a lot of stability. So even when it's extended, your robot in the bottom could move and it would provide lots of efficiency. And also, as the robot moves, there are actually some points where there's some string attached, and this string makes it so that the motor, every time the motor spins, it increases by 4.5 inches, and this string can help pull the slides up gradually. So overall, I think that the Viper Slide has excellent durability, as well as lots of strength and efficiency. That's it. Thank you.
Hi, my name is Arjun. I'm from Team 19853, and today I'm explaining what the claw is. The claw's purpose is to grab a hold of squaring elements and drop them at their designed location. The next one I'm going to talk about is the claw mechanism. The claw has a servo and kind of like a glove-shaped cloth, and it holds all the scoring elements and drops them where you need to. The next one I'm going to talk about is friction. So if your claw doesn't have good enough friction or grip, it will just slip through the claw and it will drop. So you want to make sure you have friction, and that's what I'm going into rubber. Rubber is really good to keep friction and grip on your robot because it holds lots of friction. And also your robot wants to have kind of, if you have it, like, you can have it anyway, but I would recommend to have like kind of spikes on it to keep scoring elements from dropping. Things to keep in mind is that your claw can be easily breakable, like you can ram it into a wall or anything. So you should always want to keep like spare parts with you whenever you go into a game, so you make sure it doesn't break. And another thing was the weight. If your arm has a lot of weight on it, then your claw you won't be able to pick up your claw and stuff. So you want to make sure you have good weight management on your robot. Thank you.